Friends, my name is Priyanshu and you are watching Statistics My Attention. In this video, we will learn about the characteristics function. It's the most usable function in the statistics. So, characteristic function, what is the characteristic function? In the simply way, we can written in this form, phi t is equal to e expectation of e to the power itx, and it's called the characteristic function of the random variable x. So what is t? So t is a real number and I is the imaginary number. What is the I? This is the iota. So I square is equal to root minus 1, and now the two conditions are if the function is discrete, so we can written in this form phi t is equal to summation pk e to the power itx, and if continuous distribution, then phi t is equal to expectation of e itx is equal to infinite to minus infinite to infinity and x e to the power itx dx. So the basic definition of the character function. Now, what is the properties of the characteristic function? So properties of the characteristic function. So first, it should be noted that the first point is it is complex valued. It is complex valued because it includes iota form, and so in this situation it is a complex valued function. And the second point, it is always exist. It is always exist. Third, so when you find any characteristic function of any distribution, so you can find any characteristic function of any distribution. So third point is phi t is continuous. It is continuous in any t. It means any value of real numbers is always continuous and is defined in every finite t interval. Every finite t, that means interval. So it is defined in every finite t interval. Fifth point is uniquely determined by the distribution. So this is the unique. The sixth point is completely complete. This is the complete function. Complete. Seventh, so this is the when we put 0 in place of t, so we get 1, and if phi t is under the mod, so it is always less than 1 or equal to 1. And 9th point is it is conjugate function. Phi t and phi minus t, this is the conjugate function. And the 10th point is phi, it generates moments. So it is able to generate moments. And now 11 point, so phi cx t is equal to phi x ct. And 12 point is the last point, phi x1 plus x2 plus xn t is equal to phi x1 t phi x2 t phi x and t. So now we have an example for you. So find the characteristic function of the binomial distribution. So the first question is find characteristic function of binomial distribution. Binomial distribution of parameters n p. And now, so first of all, what is the function of the binomial distribution? So binomial distribution is n cx p to the power x and q to the power n minus x. Now what is the phi t? For phi t is equal to expectation of exponential of itx, because this is the discrete function, this is discrete distribution, so we can use the summation instead of integral, and so e to the power I dx and x, because summation is x is equal to 0 to infinite. And now what is the fx? Fx is the function of the binomial distribution, so I dx and cx p to the power x q to the power n minus x. Now summation cx p e I t to the power x and q to the power n minus x. And now if you see that ncx and q is same as the real function of the binomial distribution, but the p is changed in p e to the power it. So when we q p, so p is written as p e to the power it to the power n. So this is the characteristic function of the binomial distribution. Now the second question is find the characteristic function of the random variable x, where x takes the values x1 is equal to -1 and x2 is equal to +1 with probabilities px -1. So find characteristic function of the random variable x, where x takes x1 is equal to -1 and x2 is equal to +1 with probabilities p x equal to -1 equal to p x equal to 1 is equal to 1 by 2. So this is the probability of the +1 and the -1 is equal to 1 by 2. And now the question is, how can we find the characteristic function? So first of all, we write the form of the characteristic function. Phi t is equal to expectation of exponential of itx. Now because of the two values, we write these two values in form, so p1 e I t x1 and p2 e I t x2. So it e to the power it. So what is the value of the p1 and the p2? P1 and p2 is equal to 1 by 2. So we can put the values of the p1 and p2 in place of p1, p or p2. So 1 by 2 e to the power minus it plus 1 upon 2 e to the power it. So what is the x1? X1 is equal to minus 1 and the plus 1. So here we put the values of minus 1, and here we put the values of plus 1 as well. Now the common 1 by 2, and now the e to the power minus it and plus e to the power it, which is called cos t. The formula of cos t is equal to this. And now the third question is the random variable x has a rectangular distribution. So we have given a rectangular distribution, and the function of this rectangular distribution fx is equal to 1 by 2h, and limits a minus h, a plus h, and 0 otherwise. Now find characteristic function. So how can we find this? Let's get started. Answer. So first of all, we write the form of the characteristic function: expectation of exponential itx. And now, because we have given the limits of the, and it is also a continuous function, we use the integral and a minus h, a plus h, and the function is 1 by 2h, and that's it, e to the power itx, and function is 1 upon 2h and dx, because 1 upon 2x h is constant. So now when we solve this idx and we integrate, after the integrate, so the value of integration of eidx is eidx upon it, a minus h and a plus h. Now we put these values in the place of x, and now at a to the power it, a plus h, minus e it, a minus h. So this is the answer of, but you can also write this in this form. So this is the last formula of our question.